In this video, I'll discuss problem solving from Clairaut's form. Here, the problem is obtain the complete primitive and singular solution of two equations. So, I will solve the second one, and the first one is for u. So, what the second equation can be written as? This equation can be written as just put dy dx equals p. Then the equation will be looks like sine px cosine y equals cosine xp sine y plus p. Okay, so this can be written as px cosine y minus cosine xp sine y equals p, or this is sine px minus y equals p, or px minus y equals sine inverse p, or we can write this as y equals px minus sine inverse p. Okay, let's name it equation star. And see, this is a equation of Clairaut's form, and we can easily solve this. So, but here the question is we have to find the singular solution too. So, for that, just differentiate star with respect to x. What we will get? Dy dx, and that is p. So derivative of px, so p derivative of x with respect to x is 1 plus x times dp dx, and minus the derivative of sine inverse p, that is 1 upon root over 1 minus p square, and the derivative of p with respect to x is dp dx. So p get cancelled. We will have x minus 1 upon root over 1 minus p square times dp dx equals 0. So from here we have either dp dx equals 0 or x minus 1 upon root over 1 minus p square equals 0. So dp dx equals to 0. From here we will get p equals c by integration, and c is arbitrary constant. And if we put the value in back to the ester, we will get the general solution. So general solution is star is y equals px. So y equals cx minus sine inverse c. This is the general solution. And the second question is we need to find the singular solution. That will come from this rectangular box. So let's copy this thing in the next page so that we can solve it. So from another portion we'll get x equals 1 upon root over 1 minus p square. But our star is y equals px plus sine inverse p. From here we'll get x square equals 1 upon 1 minus p square, or 1 minus p square equals 1 upon x square, or p square is 1 minus 1 upon x square. So we'll get p square equals x square minus 1 upon x square. But this is the equation ester. From here we'll get y equals root over x square minus 1 upon x times x plus sine inverse root over x square minus 1 upon x. So y is root over x square minus 1 plus sine inverse root over x square minus 1 upon x, and this is a singular solution. So let's review these things. We had this equation, we just manipulated and got the Clairaut's form. From here we know the singular solution is y equals cx plus sine inverse c, just by replacing the p by arbitrary constant. And for the singular solution we differentiate these things and we will get two factors. So from x minus 1 upon root over 1 minus p square we got p value, and that p value is p square value is x square minus 1 upon x square. We have taken a positive p value and put it in the equation S. We got the relation between x and y, which is a singular solution of the equation.